This is going to be part 2 of solving systems of equations by elimination. We had part 1 yesterday, but today we're going to step it up one step farther where we're looking for opposite coefficients, but we're going to have to multiply first. So let's see what that looks like. Okay, remember, in order to solve systems of equation by elimination, we are looking for opposite coefficients. That means we're looking at the x terms and the y terms and looking for opposites, and so that they can cancel out. Well, if you look here, we don't have opposite coefficients, so we're going to have to multiply one of the equations by a number to create opposite coefficients. So we basically have a couple of options here. First, you could multiply the first equation by -3. That means I could take each one of the three terms and multiply it times -3. Now remember, whatever you do to one term, you have to do to all three terms. When doing that, that would create a -6x, a -3y, and a -9. And when doing so, I created the opposite coefficients right here that I'm looking for. I have a -3y and a +3y. So that's one option I could do. Or I could multiply the second equation by 2. So I could multiply all three terms by 2. And when I do that, I get -2x plus 6y and then a -24. So I chose the second option. It doesn't matter which one you choose. They're both going to result in the same answer. But I had to do that step first to create my opposite coefficients. So now don't even look at the second equation because we've rewritten it. And you notice here in the x terms that we have opposites. We have a 2 and a -2, so they are going to cancel out. So we're looking to create opposite coefficients, so they'll eliminate. And now what do we have left? Well, we have a y, 1y, and a 6y. That is 7y. And we had a +3 plus a -24, which is a -21. So we have 7y equals -21. To solve for y, we're going to divide both sides by 7. So we know that y is -3. Now that we know what y is, we can substitute it back into one of the original equations or our new equation. You can substitute in the first one, the second one, or the one you created. They're all going to result in the same answer. I chose to substitute it into the first equation. Up here I had 2x plus y equals 3. And I know that y is -3, so for y I plugged in a -3, and here's what it looked like. 2x plus a -3 equals 3. It's a two-step equation. First I have to move the -3 to the other side by adding a +3 on both sides. Opposites cancel out. So that results in 2x equals 6. Divide both sides by 2, and our x is 3. And remember, we're looking for an ordered pair. So if we were to graph these two lines, they would cross at 3, -3. So we're just adding this step of multiplying one of the equations by something in order to create opposite coefficients. So in this example, we look, do we have opposite coefficients? We do not. We have a couple of choices. We could, I'll back this up for a minute, we could multiply the second equation by 3. That would create opposite coefficients here. Or we can multiply the second equation by a -2, which would create opposite coefficients in the y term. Either one's going to result in the same answer, but I chose to multiply the second equation by 3. In doing so, I have to multiply all three terms by 3. That's -3x plus 3y equals a -6. I've created opposite coefficients in the x terms. I have a 3x and a -3x, so they're eliminated. Now I have left 2y plus 3y, which is 5y, and a 6 and a -6, which is 0. So if we divide both sides by 5 now, we see that y is 0. Look, remember, we're looking for an ordered pair. So now we know the y of the ordered pair. We've got to plug 0 back in to one of the equations, either one of the first two or the one that you created. I chose to plug it into the first equation. It was 3x plus 2y equals 6. But now I know that y is 0. So if I plug in 0 here to y, it creates 3x plus 2 times 0 equals 6. Well, I know that 2 times 0 is 0, and that goes away. So we just have 3x equals 6. Divide both sides by 3, and x is equal to 2. So the ordered pair that we know that these lines are going to cross at is 2, 0. In this example, if I think about what I could do to multiply to make opposite coefficients, I will see that I'm going to have to actually change both equations. So there's a couple of options. You could multiply the first equation by 5, each term by 5, and the second one by a negative 7. And if I do that, I am creating opposite coefficients right here with a 35x and a negative 35x, which is what we're looking for. Or I could multiply the first one by 2, all three terms by 2, and the second equation by negative 3. And what that is going to do is create a negative 24. Let's see, the first one by a positive 2, the second one by negative 3. Two negatives make a positive. So this would be a negative 24, and this would be a positive 24. Here would be our opposite coefficients. So this time we have to multiply both of the equations in order to create those opposite coefficients that we're talking about. I chose to do the first choice. So I took the first equation and I multiplied all three terms by 5. That left me with 35x minus 60y equals a negative 110. And I'm multiplying the second equation by a negative 7. And what I do to one term, I must do to all three terms. When I do that, I get a negative 35x, a positive 56y, and a 98. Now I can do the elimination in my x terms. So I have opposites, so they cancel out. They're eliminated. And that leaves me with a negative 60y and a positive 56y. Since they are opposites, we subtract. That would be a negative 4y. And a negative 110 and a positive 98 are opposites, so we subtract, and that would be negative 12. So we have negative 4y equals negative 12. Divide both sides by negative 4, and we see that y would be equal to 3. Now we can plug 3 back into one of our equations. I just chose to plug it into the first equation. So in place of the y, I plugged in 3. So I took this equation and I plugged in 3 to y right here. And I have 7x minus 12 times 3 equals a negative 22. Two-step equation. We do our multiplication first. 7x minus 36 equals negative 22. Now we add 36 to both sides in this two-step equation. We have a positive and a negative, so we subtract, and that would be 7x equals 14, and x would be equal to 2. We are not finished until we write this as an ordered pair, which would be 2, 3. Paige has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per page, and the cardstock costs 75 cents per page. How many sheets can she buy? So we need to write some equations here. So we know that she has $7.75 to buy 12 sheets of two different items, felt and cardstock. So the sheets of felt and the cardstock have to equal 12 sheets. So we're going to write two equations. One's based on the number of sheets, and one equation is going to be on the cost. So let's just focus on the number of sheets. We know there's 12 sheets of both felt and cardstock. So if we wrote that, I started with the money here, it would just be the number of felt plus the number of cardstock equals 12. For the money, we know that they were 50 cents for felt, so that's where I got my 50 cents times the number of felt pieces that you bought. It was 75 cents per cardstock, so that was my 75 cents times the number of cardstock you bought, and the total cost was $7.75. So one equation was based on the cost, one equation was based on the number that she bought. Now, if we are going to solve this by elimination, we have to create opposite coefficients. So what I did was I took my second equation and I took the second equation right here and I multiplied it times 50 cents or 5/10 or 50 hundredths by each one, a negative 50 cents. When I multiply this times 12, I get a negative $6. When I multiply it times F and C, I get both negative 50 cents and negative 50 cents. And what I did there was create my opposite coefficients with the felt pieces. I have a positive 50 cents and a negative 50 cents, so they're eliminated. And then I solved the left side of the equation. I had $7.75 minus $6, which is $1.75. And for the cardstock, I had 75 cents minus 50 cents, which is 25 cents. Now to figure out the cardstock, I just divide both sides by 25 cents. So cardstock was 7 sheets. Now if I plug that back into the equation, which we talked about right here, the number for each one, I know I bought 12 sheets total. 7 of them were cardstock. I can plug that in, subtract 12 minus 7, and the number of felt is 5 sheets. So it's 5 sheets of felt and 7 sheets of cardstock. So you had to write the equation, one equation based on the cost, one equation based on the number. Then to solve by elimination, I had to create opposite coefficients right here. And then I solved the way we've been discussing. Sam spent $24.75 to buy 12 flowers for his mother. The bouquet contained roses and daisies. The cost of a rose is $2.50 and the cost of a daisy is $1.75. How many of each type? Again, we have to write 2 equations. One of the equations is going to be based on cost, total cost, and the cost for each flower. The other equation is going to be based on the number of flowers. We know the total number, and we know there were 2 different kinds. So let's write those 2 equations. We know the number of roses and the number of daisies equals 12. So this equation was based on the number of flowers he bought. The second equation, we know it was $2.50 for a daisy. So I had $2.50 $2.50 for a rose. So that's $2.50R. $1.75 for a daisy. So that's $1.75D. And the total cost was $24.75. Now, to create opposite coefficients, I can either do a negative 250 or I can do a negative 175 for each of the 3 terms. So let's see, I think I'll do the negative $2.50 times each term here to create my opposite coefficients. So that would be a negative 250 for the roses, a negative 250 for the daisies, and then 12 times $2.50 is $30. Negative $30 because we had a negative. We created our opposite coefficients, so the 250 and the minus 250 are eliminated. We have a positive 175 and a negative 250, so I subtract them, and that would be a negative 75 cents for the daisies. I have a positive 24.75 and a negative $30, so I'm going to subtract them, and that would be negative $5.25. Now if I divide 75 cents on both sides of the equation, I will find out that the number of daisies would be 7. And then when I plug 7 back into the first equation, we find out the number of roses is 5. So again, we created our opposite coefficients in order to solve systems of equations by elimination.